So in the fourth part, A part, this is the semi-infinite wire, right? Current is I. Now it turns into the circle. The current is I, and this is the wire, semi-infinite wire. Second part, third part, right? So we have to find the magnetic field at this point. Is it clear or not, Yutal?
Yes.
So if this is the semi-infinite wire, this is the point, the distance is r. So because of this wire, magnetic field at this point, if you consider only the first part, magnetic field is into the board. So B1 is mu naught I upon 4 pi r into the board, right? This is the first part. Now you consider the second part, the current is I, right? So if it is into the, if this is the direction of current, this is into the board, right? So B2 is what? Mu naught I upon 4r. And what is the direction? Into the board. What about the third part? Don't do like this, right? Because you are thinking that it is in reverse direction, right? So if take your right hand, this is the direction of current, it is into the board, in this side, out of the board. So B3 is also, due to semi-infinite wire, mu naught I upon 4 pi into the board. If it is positive into the board, it is also taken positive. So to find the net magnetic field, the total magnetic field will be added B1 plus B2 plus B3, right? If you simplify, mu naught I upon 4r is common, 1 upon pi, 1 upon pi. So it is equal to mu naught I upon 4r, 1 plus 2 upon pi. And this is into the board, right? It is positive, mean it is into the board. It is positive, mean it is into the board, right? Copy this. So in this question, hello, Kashish. This is the first part, this is the second part, this is the third part. So this is the infinite, semi-infinite wire, right? So this is the first part, and because of this, if this is the current like this, up in the this portion, the magnetic field is out. So magnetic field is what? Say into the board, right? So because of this semi-infinite wire, right? Because of this semi-infinite wire, the magnetic field is what? Say into the board, right? The B1 is mu naught I upon 4 pi r, and it is into the board. Is it clear or not? And if you consider this is the third part, because of that, this third part, the magnetic field is into the board and this side out of the board, but we have to write the magnetic field at this point. So it is into the board. So B3 is due to the semi-infinite wire, it is into the board, right? But if you consider this is the current I, and this is what? Semicircle. And because of this semicircle, the current is what? Tell me. It is out of the board. So B2, due to the B2 is mu naught I upon 4r, right? And due to this second part, the current is out of the board, right? So if you take this is the into the board is positive and into the board is positive, then you have to take this is negative. Is it clear or not, Yutal? So the total magnetic field is what? B1, right, plus minus B2, right, plus B3. Are you getting or not, Yutal? Right. So B1 is mu naught I upon 4 pi r. B2 is what? Mu naught I upon 4r. Mu naught I upon 4 pi r. So it is mu naught I upon 2 pi r, mu naught I upon 4r. Is it clear or not, Yutal?
Yes.
Right. So this is the thing. So is it positive or negative, you tell? Mu naught I upon 2r, if you take common, then what will you get? 1 upon pi minus 1 upon 4, right? So it comes to be mu naught I upon 2r, 4 minus pi upon 4 pi. It is positive. Therefore, positive take is the into the board, right? Copy this. So this is the fifth A part, right? In this part, this is the I, current carrying wire I, right? And this is the, right? This is the second part, and this is the third part. Is it clear or not, you tell? This is the first part, this is the second part, and this is the third part. Are you getting or not?
Yes.
And suppose this is the radius r, all right? Fine. So this is the semi-infinite wire. This is the semi-infinite wire or not, you tell? Because of this semi-infinite wire, the current is, this is the I. Tell me, this is the one part, this is the current I. What is that? The magnetic field is, due to this current, is out of the board. It is into the board. It is out of the board. At this point O, because of this wire, the magnetic field is out of the board. So B1 is mu naught I upon, due to semi-infinite wire, mu naught I upon 4 pi r. And the direction of the current is out of the board. Right. Now this is the circle, right? This is the circular R. And if you consider the O, what is the angle? Tell me.
3 pi by
Very good. 3 pi by 2.
2.
Right? 3 pi by. Are you getting? This is pi by 2. This is pi by 2, pi by 2. 3 quarters are there. Each quarter making angle pi by 2. So due to the 3 quarters, the angle is theta. So due to circular arc, if you remember, the magnetic field is mu naught I upon 2r due to complete circle, and theta upon 2 pi due to the circular arc. So this is the current I. The magnetic field is, tell me, out of the board. So it is mu naught I upon 2r. And what is the theta? Say 3 pi by 2 upon 2 pi. So mu naught I upon, tell me, it is 2r, 3 upon 4. 3 mu naught I upon 8r. Is it clear or not?
Yes.
And pi will cancel out, and it is out of the board. Is it clear or not, you tell? So because of this part, the current, the magnetic field is out of the board. Are you getting or not, you tell?
Yes.
This is the I, right?
Yes.
And this is the third part, all right?
Yes.
And can you tell me, this point lies on the line of the third part?
Yes.
Although from here to here it may consider the semi-infinite wire, but this is the point O lies on the line of the wire. So what is the magnetic field B3?
0.
0. So it is out, maybe assume positive. It is out, maybe assume positive, right? So then what is the net magnetic field, you tell? Is equal to B1, yes, B2 plus B3. It is 0, although B1 is mu naught I upon 4 pi r, and this is also 3 mu naught I upon 8 r, right, plus 0. And this is, all the magnetic field is out of the board, right? Copy this. So the B part, this is the semi-infinite wire, right? This is the quarter circle. This is the semi-infinite wire. Is it clear or not?
Yes.
Right, the current is I. Fine. The another part, this is the semi-infinite wire. Then this is the quarter circle. This is the current carrying wire. All right.
Yes.
And you have to find at the point O. Are you getting or not, you tell? Now these are the 6 part. This is the semi-infinite wire. This is the quarter circle. This is the semi-infinite wire, right?
Yes.
This is the semi-infinite wire. This is the quarter circle, all right?
Yes.
And this is the semi-infinite wire. So how many parts are there? 6. And we have to find the magnetic field at O. Are you getting? Yes. So I will give you 1 minute to think about this. So because of this semi-infinite wire, what is the direction of magnetic field? Out. Because of this wire, this side is in, this side is out. And because of this quarter circle, out. Because of this, out. Out, out, out. All right. Because of this semi-infinite wire, mu naught I upon. Because of this quarter circle, mu naught I upon 8R. Because of this semi-infinite wire,
U naught 4 upon 4 pi.
and this is out, out, out. Fine.
Yes.
This is the wire, and the point lies on the line of the wire. B4 is equal to
It is 0.
0. This is the quarter circle.
Yes. U naught upon 8.
Direction
Yes.
out. D5 is 8R. And because of this 6 part, 0. Why it is 0? Because the point O lies on the line of the wire. This is out, this is out, this is out, and this is out. So if out is taken the positive, all magnetic fields are added up, while V4 and V6 are 0. Is it clear or not, you tell? So the net magnetic field at O is nothing but mu naught I upon 4 pi r plus mu naught I upon 4 pi r. So multiply by 2 plus mu naught I upon 8r plus mu naught I upon 8r. Multiply by 2. Right? So it is equal to mu naught I upon 2 pi r upon 4r. All right. So this is the net magnetic field at point O. All right. This is the net magnetic field. Right. Copy this. Okay. So this is the fourth A part. This is the current carrying wire. And this is the circle, 3/4 of the circle. And this is the I. All right. This is R and this is R. This is 90 degree. All right. So tell me, this is the first part. What is the magnetic field? This lies on the line of the wire. Say B1 is equal to 0. Right. And this is the third part. Right. This is B3 is equal to 0. All right. And only this is the second part. This is the magnetic field into the board. And B2 is nothing but mu naught I upon, due to complete circle, it is 2r theta upon 2 pi. All right. This is theta is equal to 3 pi by 2. Are you getting or not?
Yes, sir.
So here the B2 is what? Mu naught I upon 2r. What is theta? It is 3 pi by 2 upon 2 pi. It is equal to mu naught I upon 2r 3 upon 4. 3 mu naught I upon 8r. It is into the board. Right? This is the magnetic field. Copy this. B part. This is the current I, right? This is the current I, right? And this is the point O, all right? This is the radius R and this is radius 2R. Fine. So how many parts are there? This is the one part, this is the two part, and this is the three part, and this is the fourth part. Is it clear or not, you tell?
Yes, sir.
Fine. So listen, if you consider the second part, the point O lies on the line of the wire. Tell me. And this is the fourth, the point O lies on the fourth part of the wire, line of the fourth part of the wire. So because of this and because of this, the magnetic field is what? 0. And this angle is pi by 3. All right. So this is out of the board, out of the board, out of the board, right? So because of one part, the magnetic field is, what is the radius? First consider the complete circle, it is 2r theta upon 2 pi. Is it clear or not, you tell?
Yes.
Fine. And what is the theta? Mu naught I upon 2r pi by 3 upon 2 pi. Mu naught I upon 3 दूनी 6 दूनी 12r. It is B1. Is it clear or not, you tell?
Yes.
Now, if you consider this the third part, the magnetic field is into the board, right? And the radius of this is 2r. It is out. Tell me, because of this part, it is out, and because of third part, it is out. It is into the board, right? Into. Are you getting this thing or not, you tell?
Yes.
If this is the current in this loop, right, like this, so the magnetic field is what? Say into the board, right? It is into the board. So the B3 is mu naught I upon I'm writing this side, no, mu naught I upon 2r, mu naught I upon 2r theta upon 2 pi, right? So this is equal to mu naught I upon 4r pi by 3 upon 2 pi. Mu naught I upon 3 दूनी 6, 6 चौक 24, 24r. Is it clear or not?
Yes.
So this is into the plane, this is out of the plane. Which is greater? B1 is greater, right? So what is the net magnetic field at O? It is equal to, if you take this is the positive, it has to taken with negative sign, mu naught I upon 12r minus mu naught I upon 24r. So it is 24r to mu naught I minus mu naught I is equal to mu naught I upon 24r is equal to B naught. Is it clear or not?
Yes.
And if it is positive and we have chosen positive as the outward, so the net magnetic field is out of the board, right? Copy this.
Correct.
So in this question illustration, the magnetic field at point A, you have to find the given current distribution. Suppose this is the 5 ampere, right? And this is the loop. So if this 5 ampere goes, so 2.5 ampere and 2.5 ampere equally current will goes or not, you tell? And by the KCL, right? And then 2.5 plus 2.5, it become 5 ampere. Are you getting or not? And you have to find the magnetic field at the point O. Is it clear or not, you tell? So this is the one part, this is the second part, and this is the third part, this is the fourth part. The radius assumed to be r, the diameter is 10 centimeter, so radius is 5 centimeter. Is it clear or not, you tell?
Yes.
So this is the one part. Due to this one part, semi-infinite, The current supposed to be I at this point. What is the magnetic field? Say out of the board. Out of the board. So B1 is mu naught I upon 4 pi r. This is out of the board. Is it clear or not, you tell? Listen, this is semicircle. This is second part. This is second part. Because of this second part, the current is what? Out.
Yes.
And because of this third part, the current is what? Say in. Due to this out, this is in. B is equal to what? Mu naught I upon 4R. It is out. Is it clear or not? B3 is mu naught I upon 4R. Right?
Yes.
And this is into the board. Are you getting or not?
Yes.
So both will cancel each other.
Yes.
So because of this part and this part, the magnetic field is equal and opposite.
Yes.
So the B2 and B3 will cancel each other. So don't consider that. Now consider the fourth part. This is the fourth part. And this is the current I. So the magnetic field is what? At this point. Please tell.
So it is outside.
Outside. This is the current outside. This side inside, this side outside. So because of fourth part, mu naught I upon, it is what? Semi-infinite wire.
Yes. Goodbye.
Right? And this, I am not considering the magnetic field due to B2 and B3 because they neutralize. So what is the net magnetic field you will write? This, if you take positive, this you have to take positive because both are out. So 2 times, both are same, mu naught I upon 4 pi r. So mu naught I upon 2 pi r. Right? So mu naught is what? 4 pi into 10 ki power minus 7. Into 10 ki power minus 7. What is the current value given in the question? Please tell. It is 5 ampere. It is 2 pi and the radius is 5 centimeter. Right? So it is 2 into 10 ki power minus 7 minus 2 minus 5. And this is out of the board. Right? This is out of the board. The option first is the correct option. Right? Copy this. So read this question. In this question, right, the current is coming from infinity. Right? This is the circular semicircle. This part is called ABC. Right? And this part is called ADC. Is it clear or not?
Yes.
ADC. And this is the infinite wire. All right. The radius is to be R. Right. What is the resistance of this part, you tell? It is 5 ohm. The resistance of this part is 10 ohm. Are you getting or not, you tell? So listen, do you know the current? If this is, suppose the current will not be the same because I is equal to what? Is equal to I1 plus I2 here, and both resistance are in parallel. So I1 R1 is equal to what? I2 R2. What is R1? 5. What is R2? 10. So I1 is equal to I2. You understand this or not?
Yes.
Please tell. It is 2I2 plus I2. It is equal to 3I2. So what is the current I2? I by 3. If current I is coming, so the I1 and I2, the I1 in this branch, in this upper part, I by 3, and I2 will be equal to what? Sorry, this is I2. I2 is I by 3. And what is I1? 2I2 mean? It is 2I by 3. Is it clear or not? You tell, please.
Yes.
Listen, this is the first part of the wire. Point lies on the wire. So what is the magnetic field due to this portion? 0. And because of fourth part, the magnetic field is what? It's 0. Is it clear or not, you tell? Because of second part, what is the direction of magnetic field? Say into the board. And because of this part, the current is what? Out of the board. Into the board, out of the board. So if B2 is what? Mu naught I upon say 4R. Right? And what is the B3? Because of this third part, mu naught I2. This is I1 upon 4R. Is it clear or not, you tell?
Yes.
This magnetic field is into the board. This magnetic field is out of the board. Is it clear or not, you tell?
Yes.
Right. I am writing the radius is small r here. Is it clear? So what is the, I am writing this side. The B2. Tell me. Mu naught upon 4R. What they are asking? Okay, the current is I. Magnetic field. So the current is I1. It is 2I by 3. So it is mu naught I upon 6R. It is into the board. What is the B3? Mu naught upon 4R. I2 value is I by 3. Mu naught I upon, and it is out of the board. Which is greater? Yes, B2 is greater. So take it positive, take it negative. So what is the net magnetic field? Mu naught I upon 6R minus mu naught I upon 12R. So when you will simplify, the 12R is LCM, mu naught I minus mu naught I. It is equal to mu naught I upon 12R. And when it is positive, right? This is the thing. Copy this.
So we are using the resistance to find I1 and I2.
Say we are using
The resistance to find I1 and I2.
Listen, this is the current divided rule. Listen, this current I goes divided into I1 plus I2. If this current is I, it is going into I1 and I2. So is it KCL or not, you tell?
Yes, sir.
Right. Also, these two resistance are in parallel. If this is the resistance R1 and R2, right? This I1 plus I1 become again I. So these two resistance are in parallel. So therefore, the potential difference. What is the potential difference across this resistance? V is equal to I1 R1 is equal to I2 R2. I1 R1 is equal to I2 R2. Right? So this is the one relation using the KCL, and this is due to the potential differences same, since both resistance are in parallel. So simplify this and this, you will get the value of I1 and I2 in terms of capital I. So if this is the current I, this is I1 and this is I2, right? Put here value I1 and I2, then you can get the answer. Is it clear or not, you tell, please? Copy this. So now we discuss few theory, right? The very important illustration, or you can assume to be theory, right? For example, suppose this is a circle, right? And the current is coming to be I, all right? And this is the point O. When current enters here, so some I1 and I2 the current is divided in two parts, and suppose, right, this part is making angle theta over here. It flows in this part, right? It become I1 and I2 again the I. Is it clear or not, you tell?
Yes, sir.
So in this case, you have to find, I'm writing the question, find magnetic field, find magnetic induction at the center, right, of figure given below, right, figure given below, right?
Yes.
So you have to find the magnetic field here, right? So copy this and think about this. I will give you 1 minute. So how to solve this question? Please look at the board. Listen, if this is I, because of this infinite part, the magnetic field due to this part will be 0 or not? And this is the infinite part, B4 will be 0 or not? Because it lies, this point lies on the line of the wire, right? This is the circular arc of the current carrying wire, and this current carrying wire is uniform, right? Uniform mean its length is uniform, its area is uniform, right? So consider, first we have to find the resistance of this part is supposed to be R1 and this part is supposed to be R2. Is it clear or not, you tell?
Yes.
So if this is theta is the second part, right? If this length is what? Supposed to L2?
Yes.
This length is L2. And the resistivity of the wire is rho, right? And the resistivity, right? And the area of this cross section of this wire, this is the wire like this, right?
Yes.
This is the wire. So it will have the cross section area A, area of cross section, right?
Yes.
Area of cross section. So what is the resistance of this part, R2, is equal to rho L2 upon A. Is it clear or not, you tell?
Yes.
And if the length of this part is what? Say L1. So what is the resistance R1? Rho L1 upon A. So if you find the ratio of the resistance R2 upon R1, what will you get? L2 upon N1. Is it clear or not?
Yes.
If this angle made is theta, so what is this angle? Say 2 pi minus theta. So here angle is equal to arc upon radius. Is it clear or not? Assuming the radius is small r.
Yes.
And here the 2 pi minus theta angle is equal to arc upon radius. Is it clear or not? So divide theta upon 2 pi minus theta is equal to L2 upon L1, because R will cancel out. Is it clear or not?
Yes.
If you divide this, so R2 upon R1 is equal to what? Say L2 upon L1, and it is equal to theta upon 2 pi minus theta. So first we have found the ratio of resistance of this part and this part. Is it clear or not?
Clear.
Right. Now, if this is the current I, this is the I1, this is the I2. Although we would have the current divided rule in current electricity, but still if we don't have that, the current I, KCL, is equal to what? Say I1 plus I2.
Yes.
And both resistance are in.
Parallel.
So V is equal to I1 R1. The potential difference across this is equal to I2 R2. Is it clear or not?
Yes.
This is the thing.
Yes.
So if I1 upon R1 upon R2 is equal to I2. So put the value of I2 this side. So I is equal to I1 plus I1 R1 upon R2. If you take I1 common, R1 upon R2, it is equal to I1 R2 plus R1 upon R2. It is equal to what? Say I. So what is the value of I1? R2 upon R1 plus R2 into I. This is the value of I1. This is the value of I1 in terms of this I current. The value of I1 is this. And what is out I2? I2 is I1 R1 upon R2. It is R2 upon into I R1 upon R2. It will cancel out. Tell me, is it clear or not? You tell. First copy this. Wait for 1 minute. Okay. So now we find the B1. Because of this part, tell me, the B1 is into the boat?
Yes.
And because of this part, B2 is out. Because of one, this is suppose the second part, right? And this is the, you assume this is the second part and this is the third part. Because of second part, what is the B2? Yes, mu naught I2 upon 2R into theta upon 2 pi. Is it clear or not? You tell.
Yes.
And this is out of the board. Fine. And what about the B1? Because of this part, mu naught I1 upon 2R. And what is this theta? 2 pi minus theta upon 2 pi. And this is into the board. Right?
Yes.
So tell me, can you find the ratio B2 and B1?
Yes.
Mu naught I2 upon 2R theta upon 2 pi mu naught I1 upon 2R 2 pi minus theta upon 2 pi. Is it clear?
Yes.
It is what? I2 upon I1
Yes.
theta upon 2 pi minus theta.
Yes.
Right? Tell me, if this is the I1 and I2, so what is the ratio of I2 and I1? From here also, without doing all this thing, without solving this thing, I2 and I1, it is R1 upon R2. And what is the R1 upon R2? It is
R1 upon R2 is theta,
this,
pi minus theta upon.
yes, because it is R2 upon R1. So R1 upon R2 is 2 pi minus theta upon theta. Is it clear or not?
Yes.
It means all this thing was not necessary to do. Right?
Yes.
We can skip this. Right? Because only the potential difference is same. So if it is I1 R1 is equal to I2 R2, so I1 upon I2 is equal to R2 upon R1. And R2 upon R1 is what? Say theta upon T1. So here I2 upon I1,
R2.
this is I2 upon I1 is equal to what? 2 pi minus theta upon theta. So can you put the value?
Yes.
2 pi minus theta upon theta into theta upon 2 pi. It will cancel. So B2 upon B1 is what? 1 is to 1. What does it mean? That, yes, B1 and B2 are equal. What does it mean? It means the magnetic field produced by this part and magnetic field produced by this part is equal and
Opposite.
opposite. So they will cancel each other, and due to this part and this part, magnetic field is 0. So what is the magnetic field at the center?
0.
So therefore the magnetic field at the center is what? 0. Are you getting or not?
Yes.
It does not depend upon theta. It does not depend upon theta. Does not depends upon value of theta. Whatever the angle is this, the magnetic field at for every angle will be, magnetic field at the center for every angle will be 0, right? I'm writing this side. What does it mean? After that, you may write here, if this is the circle, the current I enters, some current I1, I2 will distribute it, and it is I. So what is the magnetic field at the center? Will be 0. Whatever the angle of theta is, if this is the I, right, and this is the, suppose 120 degree, so some part and some part will be distributed. So what is the magnetic field at the center? 0. Suppose this is the system, the half current will distribute it. It is very symmetric scenes. So still what is the magnetic field at the center is
0.
whatever the angle it is. You are getting or not? Suppose this is the current carrying wire, some current goes like this, and right, it is I1, support is I2. We are not need to find the value of I1 and I2. Suppose the angle is 60 degree over here, the current, it become I2. So what is the magnetic field at center? 0. So this is general thing, right? For every angle of theta, we have found this part magnetic field and this part magnetic field are equal, and they are in direction, they are in the opposite direction, right? So net magnetic field at the center will be 0. These are few illustrations, you can copy this, right?